Hello everyone, my name is Martin Linksfeld and I am Master Chef at foggykitchen.com. In this video, I would like to present one of the essential new features introduced in OCI in scope of volume block service. As you know, protecting your resources is fundamental as many e-business rely on the high availability and disaster recovery. Therefore, for every compute instance with block volumes, you need to prepare a good backup strategy and protection for more severe disaster, such as a region outage. In that place, block volume cross-region replication seems to be the best option. In this exercise, we will set up a simplified topology with two web servers spread between the regions. Web servers will be nested in two VCNs, interconnected with DRGs and cross-region peering. On the other hand, we will set up block volume replica in another region. Terraform code will help us to activate the replica and provision block volume based on that replica's content. Then, this new block volume will be attached to standby web server, and HTTPD services can start serving static files replicated from the original web server's block volume. Topology diagram. As you can see, we have one region and the second one, and those regions are interconnected through interconnection between DRGs, right? The backbone of OCI. In each and every region, we have VCNs, VCN1 here in region 1 and VCN2 in region 2. Inside VCN1, we will have web subnet, public one, with one web server and one block volume attached through iSCSI protocol. On the other hand, we will have web server number 2 in a second region. And as you can see, we will set up the cross-region replication, so for this block volume, the replica, in another region. It will work until we will just activate this replica, which means we will transform this replica into a snapshot block volume, and this block volume will be then attached to our second server. Now it's time to do a code review to explain how all of that will be coded in Terraform. Hey, this is my local copy of the repository, which has been downloaded directly from GitHub. I'll start our journey with providers.tf file. As you can see, we have a section defining what kind of a required version of Terraform we need and required providers. Then we have a section for OCI provider, right? We have four blocks for OCI provider. One for home region, where we are obtaining the home region from data source, and two for requester, where our web server number 1 will be deployed, and acceptor for another region, second region, where web server 2 will be deployed. We have also additional OCI provider without alias. It is necessary, believe me. Okay, and this is a provider.tf file. Next, let's go to our cloud network element. Okay, first of all, we have VCN1, right? And this VCN1 will be deployed in a first region through OCI requester provider. VCN2 will be deployed in acceptor region, region number 2. Then we have two resources for DHCP options for VCN1 and VCN2. Let me scroll it. And again, we have internet gateway for VCN1 and route rule for VCN1. as you can see here, this route rule has two rules. One to use Internet Gateway, another one to use DRG. Let me talk about DRG a little bit later. And then we have Internet Gateway, and this one is associated with VCN2. And again, we have a proper route table with two routes where traffic to the internet will go through Internet Gateway 2, and a route rule for returning traffic to VCN1 through DRG. Okay, let's scroll down. Here we have a security list for VCN1, opening ports for web service, for web protocols, and for SSH. The identical security list, but this time for VCN2. And finally, we have two subnets, right? Web subnet in VCN1 and DR subnet in VCN2, right? So in the second region. That is all in case of the infrastructure, but we have also DRGs. So as you can see here in drg_rpc.tf file, we have a first DRG in VCN1, attachment to this VCN1 as well, and we have RPC resource which will connect us to another RPC on the other side in the second region. Again, DRG2 in VCN2, attachment, and RPC2 as I have mentioned. So those elements will help us to interconnect two VCNs in two different regions. Okay, that was our infrastructure, and now we can move directly to compute.tf. In this file, as you can see, we have a first web server, and this web server will be nested in our web subnet in the first region. And we have also second web server, and this web server will be nested in DR subnet. Okay, that's all in terms of the compute instances, but we need to also talk about block volumes, right? So that's the essence of this lesson, to be fairly honest. So first of all, we have 100 gigabyte block volume, and this block volume will have a section defining replica. As you can see here, this block volume will be attached to our web server number 1. Let's return back to replica definition. First of all, this block volume replica section will let us name this replica with this string, right? On the other hand, we will put here availability domain of the second region. And here we have a section, a block for yet another block volume, but this time, as you can see, we are building this block volume with the proper data source, and this data source will obtain replicas. Let me go to datasources.tf for a sec and scroll down, and this data source will help us to find out replica which is in an available state, in a compartment which is expected, and availability domain which is expected. So returning back to block volumes.tf, this section will build the block volume directly from the replica which is located nearby, and then block volume will be associated with our web server number 2. As you can see here, we are using count to define if this resource should be built or not. It very depends on activate block volume replica variable, which is a flag to enable activation or not, right? Okay, this variable by default is defined in variables.tf and by default is set to true, which means immediately after replica will be built, this code will create a snapshot from the replica, and from the snapshot, block volume will be activated and available for web server number 2. In this exercise, we'll turn that activate block volume replica to false at the first stage, and then we will turn it on. Okay, one more thing, remote.tf file. In this file, we will connect to original web server 1, and inside this web server 1, we will run iSCSI attach sh file, which will find out all iSCSI devices. Then in the next remote exec, we will just build the partition, right, inside this file, and on top of that partition, build with mkpart utility, we will create ext4 file system, and this ext4 file system will be mounted as def sdb1 on this machine. Okay, so it means block volume will be available in a web server 1 as yet another file system. Next, we will configure the file, which is called index.html, in this mounted file system, and inside this index.html, we will put this phrase, welcome to foggykitchen.com. This index.html will be replicated to another region, right? So this index.html will be then used as a content for our web server. This section defines our httpd.conf configuration to include this index.html file. Okay, what next? Let's assume that we have activated the replica and block volume in the second region is now attached to our web server 2, right? So we are accessing this web server 2, right? We are running iSCSI shell script to obtain all necessary iSCSI devices, and after that we are just mounting this this already existing file system taken from replica in this new server, web server 2, right? And of course we are preparing again in a similar way HTTPD on the web server 2 to expose data from HTTPD data file system with index.html to outside world. So it will be a proof that replica has been replicated properly and the proper file has landed in a proper file system. Seems to be a little bit complicated, but now we will move directly to GitHub repo, and I will run deploy, and I will click deploy button, and we'll execute that code entirely in our tenancy. I'm now in my GitHub repository. Let me scroll down this README file. Here is our topology diagram, and I'm clicking on deploy to Oracle button. I will be immediately transferred to my tenancy because I have already authenticated myself, so I'm inside. I'm clicking here to accept terms and conditions. I'm choosing the proper compartment, let's say resource manager compartment, and then I'm clicking next. I'll choose Frankfurt and Amsterdam for regions, and I will deactivate, or let's say I will disable the activation of the block volume for a first Terraform deployment. I'm clicking next, and then I'm clicking create, and my Terraform will start immediately. I will pause the recording for a moment because I need to wait for this job to be finished. Looks like Terraform apply job is done. Let me scroll down, and will see Terraform apply, completed, 31 resources added, perfectly fine. Let's go to outputs, and I will pick up the first server, and I will check if I'm able to see the content visible here and created inside the file system on a block volume. Okay, that's good. Let me go directly to storage, block volumes. I need to switch the compartment to Foggy Kitchen compartment, and as you can see here, we have volume, and as you can see, we have a replica of the volume in Amsterdam region, and this is the name of the replica. As you can see, we are in the Frankfurt, so let's switch to Amsterdam and let's go to block volume replicas, and this is exactly our replica which has been built from Frankfurt, source region Frankfurt. Perfect. Okay, now let's do the trick. I will return back to Frankfurt to our resource manager, and inside resource manager I will switch the compartment and I will go to our stack and I will edit this stack, and what I will change is here. So this flag I will click, I'll check, and this means it will activate the replica. So let me run apply, and it will change, it will activate replica for us and will create the proper volume, block volume, and this block volume will be associated with our second web server. I'll pause the recording for a moment just to see that, just to wait for the job to be done. Okay, second Terraform apply is finished. So let me scroll down to see what is in output. 5 resources added, including I guess attachment of the volume to the second server, block volume number 2, which is built on the replica, right? And this block volume replica is in Amsterdam. Perfect. Okay, let's go to outputs, and I will pick up second server, and the second server I will access, and as you can see, I can see the same index HTML content, so everything has been set up properly. It is also visible in the logs. So let me scroll down again, and as you can see, here we have a proof that everything went smoothly, right? Dev SDB1 has been mounted with ext4 file system for httpd_data mount point. Okay, let's go to our storage. I will go to block volumes. Of course, I will switch the region to Amsterdam. And of course, I need to change the compartment. And as you can see, here's our block volume for web server 2, which is in Amsterdam. Let me click, and what you can see is source type block volume replica, right? So it's a replica, it's a volume built on top of the replica after cross-region replication. Okay, that is all, and this is the end of this recording. Thank you for your patience and see you soon. Thank you.